Good morning. What do we have here? Okay. Cool, we should be live. Maybe let me know in chat if you can hear me all right, and I'll start showing myself here. How do I do this? Oh yeah. Cool. Bacon hears. Awesome. And then start casting. Oh, it's already in the right place. First time ever. Cool. Tiny bubble. Is the bubble getting smaller? I don't think I can change the size. Okay, wait, I can do. Whoa. We don't want this. What is this? There we go. But then can I shrink myself? Yeah, too much. Okay, okay. Here we go. Back to this. This is better. Um Yeah, I mean I'd make it a little bigger if I could. I think this is fine though. I mean you're not here to watch me, you're here to watch me on my screen, so yeah, tiny bubble's okay, cool. Just moved here from watching Soding. How do you pronounce that guy? I've never really watched much of his stuff, but I definitely hear a lot about him. And is it just me or is it like flickering? Hey cat. It do be flickering. You've been reading your binary analysis books. Sounds great. Hold on. There we go. Now it's not flickering. Perfect. Okay. It's good now, right? It's not no longer flickering. It's not for me anyway. Cool. All right. We'll give it. Yeah, let's give it like a minute or two and wait for some people to trickle in, and then we'll jump in. Do you not upload any VODs? Yeah, I do. They're all on. If you go to here, I'll show you. If you go to my channel, and then you got it. So like videos has. This is when I was just doing videos, but live. It says it right here. Live streams are under the live tab. But if you go over to live, then these are all the past live streams, and you can watch them to your heart's content. Cool. Bring this back down here. Have you guys seen what was it? How to Build an Agent by Thorsten Ball. It's a blog post he did recently. It was really interesting. I sort of like started going through it. I don't know if I'll finish it, but just the concept's pretty interesting. It's really simple. Anyway, that's what this is right here. So I've got like this guy, and I can chat with Claude. Um, can I link it? Yeah, totally. It's this thing. You start by just making a chat like this, you know? It's kind of slow for me. But then you go on to like provide it with like tools and stuff so it can, you know, like read files and edit files and read your current directory and stuff like that. So it's pretty interesting. All right, but we're not writing agents today. We're creating a bootloader. So let's jump in. I want hold on. Stick this down here, and then make a new window over here. There we go. And then maybe shrink it down a bit. Okay. Baby step. Uh-oh. So what was the last baby step we did? Oh, I read through this, didn't I? Yeah. Okay, so baby step 4. This is the up next. All right. So I'll start by just going through probably finishing up these baby steps. I think there were 8 total, and I've already done 3, so I'll probably finish these today because they're pretty small. They are baby steps after all. And then see what would be a good place to go from there. Okay. I know this is starting to look like a half-baked tutorial on assembly, but there's actually a reason behind my madness. Namely, let me blow this up a bit. It's probably small for you guys, isn't it? How's that? There's actually a reason behind my madness. Namely, solving as many problems as possible before switching to protected mode, etc. will lessen the confusion a great deal. Have you ever tried Raylib? No, I haven't, but I've had my eye on it for a while. It looks super interesting. This example prints a string and the contents of a memory location, which is the first letter of the string in video memory. It is meant to demonstrate printing to screen in text mode without using BIOS, as well as converting hex so it can be displayed. So we can check register and memory values. Okay. Something's wrong with my left eye this morning. Okay. A stack is included, but only used by call and ret. I'm small. Yeah, I don't think I can make it bigger. Make macOS presenter overlay bigger. Yeah, you can toggle between small and large. Yeah, I don't think I can make this guy any bigger. Yep, no can do. Sorry. Yeah, Kat, could you try what Lord Paijo recommended? See if that works. Alright, let's do this. Is this supposed to, yeah, replace everything I have here? Cool. You seeing this? No, I'm not seeing anything. Does that mean it's not working? Not working? Yeah, here, 1 second. I got you, Kat. What's your I need like a this. That might have worked. Try it now, cat. See if it works. I made you an approved user. If you're trying, I'm not seeing anything. Yeah, all right. Well, I'll finagle with it after stream. I can't. I want to get into this, so maybe remind me in the Discord or something, and I'll give it a shot. All right. So okay. So it kind of like started over from scratch, no? So then you do this org thing, which tells it like the offset org 0x7C00. And then we've got XOR AX move DS AX, move SS AX, move SP 0x9C00. I'm going to comment these so I know what they are. Offsets start at OX7C00, right? And then this set AX to 0. Set. I could just do. Can I do this? 2. Should do the same thing. And same with this one. No, because DS and SS are restrictive. Oh, so I can't directly change them like that? Gotcha, I didn't know that. Stack starts at 0. Wait, what is SS? And what is DS? What are these registers? Don't allow direct operation, or it is not conventional to do so. Okay, gotcha. Move SP 0x9C00. I already did that. 200H past code start. SS is stack segment and DS is data segment. Thank you. And then we CLD, which I kind of forget what that does. And then we move AX. That. What is this? Text. What does that mean? Text video memory. Move SI message. Text string. Call sprint. Sprint we're gonna define later, I suppose. We move AX 0xB 800. Look at video mem. Move GS AX. Move BX 0x0000. Move AX GS colon BX. Not sure what this comment means, but let's add it just in case. Dub equals 57 attrib equals 0f. There are things that are explicitly added to move from some memory region that you labeled in case of DS and added to the stack in the case of SP. So like move word reg 16 this look at register. What do you even mean? Call print register 16, and then we hang Oh, wasn't I gonna try to get that language server working? Let me make that a to-do. Don't I have a to-do? No. Every good project needs a to-do. Okay. And they have like a divider strip. We don't really need a divider strip. Dochar? We compile your move word label to move word ds label. Okay. Gotcha, thank you. Dochar. Call cprint. Sprint. Lodsb. This prints one character. This string char to al. And then comp al with 0. Jump if not equal. Do char. Says else we're done. Add byte y pose. What's y pose? Y position? Where did that come from? Down one row? What is y pause? Did that come from somewhere? Is that like a built-in? Y pose. See, this is why I want a language server. All right, quick break, snack break. We're gonna install the language server. At the bottom. Oh yeah, check it out. It's right there. Gotcha. Thank you. Let us go over to dot files. And I've got like a plugins, lsp config. Oh, I decided to get rid of render markdown, which means I need to get rid of it in here. Yeah, okay. I think I have these like mostly down here. Okay. Yes, and then asm lsp. Didn't somebody in the Discord send something? Yeah, Stefan. Here we go. Okay, so let's go to. Did I already install it? Yeah, okay, I already did that. But then we'll go to lsp config. Go to all configs and find asm lsp, this guy. Burger cookie, is this the one? Yeah, burger cookie. Cool. So you just say like, I already have it right there. right here. Let's turn that on, but then that by default isn't configured right. What is this? Humble. Yeah, we got errors all over the place. So where does the configuration go? Aha. Here we go. Add a .asm lsp.toml. And then this is what Stefan gave us. Now we're getting nothing. Hi, nice to see you using ASM LSP. I'm trying. It's not wait. So if I like comment all that out, restart. Okay, so this is like what I get by default. Oops. It says to add the TOM with the project root. I did that, right? This is my project and this is the root. If I uncomment it out and then restart my language server, nothing happens. Why every time you type there's a yellow bar on your keyboard? What is that feature? It seems useful for me to use. Every time I type there's a yellow bar. Oh, this thing? Like if I, like these down here, is that what you're talking about? There's a yellow bar on your keyboard? I'm not sure what else you'd be talking about. Yeah, that's something called like this. This is called Keycaster, I think, right? Keycaster. Keycaster. That's just so you guys can see what I type. I definitely don't use it when I'm not streaming though. But yeah, this is it. This is only for Mac OS, I think. I'm not sure. Here, I'll send here's the link. All right, let's try reading from this documentation. Get rid of that. All right, asm lsp.toml. So if I go over to boot, there's problems. Okay, perfect. Optional, configure, add that to the root directory and or there. Okay. Selectively target by default diagnostics are enabled, and the server attempts to invoke GCC and then claim to generate them. If the compiler config field is specified, the server will attempt. Okay. Yada yada. Config builder. Creating it manually is fine, but can be error prone as projects grow in complexity. Running gen config. Oh, perfect. Hey, Josue. All right, so we can do asm lsp gen config. Create default config. Sure. x86-64. NASM. Yeah, that's good. Pilot uses compiler flags files. I don't know. It's probably fine. Enter compiler. Oh dear, that's not what I wanted. NASM. Hold on, stop it right there. Try this again. Okay. x86-64. NASM. That's fine. Let's not do that. Enable diagnostic features, yeah. Attempt to provide diagnostics if no compilation information can be found for a source file, sure. Add a new project config, sure. This directory. Yes. I thought I already went through this. What? It's a vicious cycle. Let's try source. Wait, I'm in a vicious cycle. Oh, did I do it? There we go. Okay, so there's one here now. That's why I accidentally got for the source. Okay, gotcha. Default config, private ops. Let's go with that. Okay, so that should be. Is that you who's getting Discord notifications or me? Oh, it might be me. I don't have my headphones on. Here, let me there we go. Try this. So now we have that, and if I go to here, then it's here. What if I move this up into source? Yeah, this isn't working for me. All right. Well, I don't want to spend much time on that. So we're gonna get rid of it. Okay, no LSP for us today. Back to here. Where were we? Do char, sprint. Why does this formatting look so bad? All right, we add byte to y pose and x pose 0. Return, then we cprint. Move atch 0x0f. I feel like this looks better if it's on a new line. This should go here. This should go here. Return. Yep, good catch. Thank you. All right, then we move cx ax. Move. What's move zx? Is it like move the X, but with like a French accent? Moves the X. AX byte Y pose. Oh yeah, we're gonna add these comments down one row. Back to left. This is supposed to be a mauve. That makes more sense. Okay. So this whole thing is like a carriage return. And then this says attrib equals white on black. So this is saying the color, I guess. This is save char attribute. Then we move dx 160. I don't know what this is. What is it? 2 bytes. Char attrib. And then we mul dx for 80 columns. And then move zx. What is move zx? Bx byte expose. See, because this is not in long mode, all these registers to me are like unknown. Because I'm used to like RAX and RSI and RDI and all those. Oh, the GS and the OXB800 is the address of the memory mapped VGA text buffer. Wait, what one? GS. Here. And here. Gotcha. So that's what video memory is referring to, the VGA buffer? I remember doing some stuff in the past with the VGA buffer. Shul bx1 times 2 to indeed. Okay, cool. To skip attribute. So all this is just going to be writing to VGA, right? Is that correct? Hey, Tez. And then move die 0. Move, no, add. Oh wait, we need comments. Start of video memory. Move die, no, add die ix. Add y offset. And then add bi bx. Add x offset. Des is basically just giving me a daily high. It's alright, I appreciate the daily high. Move ax cx. Restore char attribute. Stow stub. I don't know what that does. Write char attribute. Add byte. Expose 1. Advance to the right. And return. Cool. What's the convention for assembly? You're supposed to like align these. The comments. Like this. I feel like this looks kind of nice when you do it this way. Store signed word, is that what this is? Whatever you want, but yeah, aligned. You don't use comments? I will forget what every single line does if I don't use comments. I feel like I kind of need them. This to me looks nice. And now that we're writing real humble OS code, we need to have a nice code base. Okay. Although who knows if we're going to keep this. You have 5K TASM assembly project and no comments. That's impressive. Yeah, 5K lines. That's kind of what I assumed. There's that. There's that. There's that. Is there an ASM formatter I could use? Surely there's an ASM formatter. ASM this thing? You really understand ASM just like that? I don't even understand a bit. I understand kind of at a high level what's going on, but I don't understand. I mean, I understand what most of these commands mean. I don't know what movesex means, and I just learned that this means stored signed word. But I'm definitely just now beginning to understand kind of some of this stuff. ASM formatter. Designed for MASM. So this isn't going to work for me, right? I need NASM, don't I? NASM. NASM format. Formatter for NASM source files. Try this maybe? Really liking both your projects right now. Thank you so much. Appreciate that. Hey, anybody have a recommendation for a formatter? This is the one I found. Let me see if there's any. It's got like nothing. This thing's a little more recent. Oh, this one only has 4 stars. Looks like people don't like to format their assembly. All right, I guess we'll just go with the crowd. As bad as that life advice might be in general. Shoink. All right, now we're all lined up. So pretty. Okay. All right, but there's more. Where that came from. There's all sorts of goodies down here. Let's add these divider lines. They look kind of nice, no? They have one right after hang. Shoink. Let's add another one right here. We already got all that. Okay. MASM is 32-bit. Oh, gotcha. So that'd be what, protected mode, right? Yeah, I'd want every function. Super nice. Okay, cool. Print reg 16. Move di out stir 16. What in the world is out stir 16? Oh, it's one of these. Okay, there's a bunch of variables down here. Is it normal to like, or not variables, constants, right? Is it normal to define this stuff down at the bottom? Move ax reg 16. I guess these aren't necessarily constants, are they? These can be changed. Move si x stir. Move cx for. This says for places. Then we have a hex loop. Roll. What's roll? Index into hex stir. TASM, MASM, and NASM are the Intel assembly compilers for x64, 16-bit, 32-bit, and 64-bit. Oh, I didn't realize that. So TASM, MASM, and NASM. Whatever you want, but I guess at the end right now, because your code right now is executable from the start of the file, so you can't really change the order unless you use sections. Oh, gotcha. Seems you were close, and stow stub is store string word. Oh, gotcha. It's not signed word. All right. And then we do another mob, right? Mob di bl, and then we inc di, and then we dec cx, and then we jins x loop. And then we move si out stir 16, and we call sprint, and then we ret. And then we have one of these cool dividers. Shoink. And then we define these things. xdb0, y pose db0, hex stir db0. Okay, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, a, b, c, d, e, f. And then we out stir 16 db 0000 0. That's a null terminated, right? This is the register value string. Then reg 16 ddub 0, there's no comma. Pass values to print reg 16. This needs to be aligned with this comment. And then message db. What are you doing, Dave? Who's Dave? And then terminate it. Sorry, null terminate. And times. Oh, this fills up the rest, right? 5, 10, because need to be 5, 12. Cha-ching minus cha-ching, cha-ching, and then db0. db0x55, and the double A thing. It's a reference to a movie. Not a movie I've seen, evidently. That's funny. I'm gonna change to something else. Hi. Cement is tasty. How's that? Cool. Am I supposed to try this thing now? Don't I have like a just what do I have? Assemble bootloader, and then just run. A Space Odyssey. Yeah, I haven't seen it. Image format was not specified for boot.bin, and probing guessed raw. Automatically detecting the format is dangerous for raw images. Write operations on block 0 will be restricted. Specify the raw format explicitly to remove the restrictions. We got problems, Houston. Is it gonna tell me how to run it over here? Oh, top comments of the code. Yeah, I do remember that. This, right? The NASM dub is for Windows, right? So I say NASM boot.asm -f bin -o boot.bin. What's this part copy? I don't have such a thing. Do I need that? What's part copy? Part copy? That's beautiful. I don't know. Brew install part copy? Nope. I feel like he was telling us to use that before and we didn't have to use it. Didn't it? Yeah. We didn't actually need it. Hmm. 2, 3, 4. So I'm not sure what's going on here. Surely something will come up if I Google this. Ta-da. Oh, sweet. This is perfect. The reason for this is that Kimu is automatically guessing the format of your disk image is raw. The problem with doing that is that your guest was able to write the whole raw image. It can maliciously say that disk header. Okay. Notice Kimu refuses to allow the guest to write the start. Okay. To fix this, you explicitly tell Kimu that the image is in raw format, but you can't do that with the convenience short options or with the just pass a disk. You need to use the long format options to specify your disk image so that you can pass it a format equals raw. In this case, that would be this. Gotcha. Let's try it. Okay, so we're gonna try Kimu this. So I have to do drive file equals boot.bin comma format equals raw, comma index equals 0, comma media equals disk. So now we're not getting the oh, check it out. Cement is tasty. And then we're getting that. Hey. That worked. Okay, so then we can just replace our just run with this bad boy. Cat, you feel amazing. Okay, so now I can just assemble bootloader. Is that what I called it? And then just run. And we get this. Cool. Where is this coming from? Is this the joink? Oh, print reg 16. That's probably where that's coming from. We're calling sprint, shoink, and then we're calling print reg 16. So those are those two things. Coolio. So now we can like write to here. Cool. And now we'll go to baby step 5. You hacked my PC, not really, but OMG. Kind of. You hacked my mind, is what you did. This code is meant to show how the hardware interrupt generated when you press a key can be handled by replacing the seg offset specified in IVT. This normally points to a BIOS run routine. To find the entry in the IVT, multiply the interrupt number by 4, which is the size of each entry. This key handler just displays the scan code without conversion to ASCII, buffering, or handling extended keys. The reason for doing this is to not muddle up the basic idea, which is to provide input as well as output in its most simplest form. I will not go into hows and whys of reading the ports involved. So we're doing keyboard input already. This is super cool. Suffice it to say that you are communicating with actual chips or parts of chips, not some software intermediary. I personally feel it is good to remember that no matter what level of abstraction you work at, you are ultimately telling hardware what to do. I will point out that turning the keyboard on-off through port 0x61 is given in its complete form, some of which might not be needed depending on the system. Wait, what is this? Oh, they moved the printing routines into a new file. Is it normal to start your ASM files with something like this? Probably not. That's probably just what this is saying. Okay, so I'm gonna make a new one called I'm gonna switch from my source model to bootloader directory. I think that's cleaner. We don't need the source thing. I'm gonna add a print.inc, which has dochar, has sprint, has cprint. It has all this stuff. Return xpose, ypose, hex string out. It has all of this. Joink goes into here. Can I call it print.asm? And then in this one, we actually have a start now. Interesting. Okay, so we're gonna change all this. He's referring to making a PlayStation 2 driver right now. That's probably what not we mean by PS2. Org ox7c00 jump start. Include nice videos, thank you. Include print. I named mine asm, right? So we'll do that, and then start XOR. Wait, why does it do this? This looks a lot nicer. XOR AX move DS AX move SS AX move SP 0x9c00 move AX 0xb800 move ES AX CLI move BX 0x09 Shoal BX2. What's SHL? PS2 is a port and a protocol on your PC like USB that allows for keyboard and mice to work. It works by sending a key to the PS2 controller to stop the CPU and jump to the keyboard mice handler. Oh, cool. The handler then pulls the data from the PS2 controller through that port. Gotcha, thank you. SHL stands for shift left. Gotcha, thank you. XOR AX move GSAX move GS:BX. Oh wait, I missed something here. Word key handler. What's key handler? Oh, it's a function later. Okay. Move GS:BX plus 2 DS and then STI. What's STI? Jump to there. That means jump to the beginning, right? And then key handler in AL 0x60. Currently, you're just overriding the keyboard handler with your keyboard handler. Move VL AL. Move byte port 60 AL. in AL 0x61, move AHAL or AL 0x80 out 0x61. I feel like I should be commenting this. This get key data, save it. Keyboard control. Disable bit 7. Why? I don't know. Set. Oh no. Send it back. Okay. And then Xichug. What's Xichug? Anybody know? I missed something here. Shoink IL. Sty is to set interrupt flag, you think? Cool, okay. There's a special vector of functions that are called when some hardware interrupt or software interrupt happens and stops the execution of the CPU and jumps to that function. Exchange, okay. Exchange what? Oh, like switch these two, the values in these two registers? Is that what that is? Get original out 0x61. That's interesting. AL send that back. Move AL 0x20 and up interrupt. Out 0x20 AL and BL 0x80. Jins jump if not 0 to done. And then move AL 0x20 out 0x20 AL and BL. Oh wait, sorry, I was reading that wrong. I jumped back. Okay, this is key released. This is don't repeat. Okay. Then we say move AX port 60. Then we move word reg 16 AX, and then we call print reg 16. And then we're done. iret. Wait, what was iret again? And then we say port 60 is a DW 0. And then we're going to say times 5, 10, shoink, okay, DB0. iret is interrupt return, I think. Okay. And then we DW 0xAA55. Sorry, you send a text real quick. Okay. Cool. Should be. So the data that the keyboard / PS2 controller gives you is a scan code, like the position of the key on the keyboard, and you need to translate it. Gotcha. So translating is something I'll eventually have to do myself manually, I'm assuming. We already got that. So let's try it, no? Print. Do I need to say like bootloader? Kind of doubt it. Yeah. Wait, so it's not happy with this. Do I need to assemble both of them? No such file directory. This is missing a comma. Check the comment how they compile it. It's the same. That worked. That worked. Oh my goodness, I'm typing. Do you guys see that? I'm gonna change this just file to like cd bootloader. Okay, so now I'm not gonna have this boot. Yeah, okay. So now if I just assemble the bootloader, oops. What do you mean? You figured it's a working directory thing? Yeah, that's what it was. But why is this not working? What if I do that? There we go. Okay, that works. So if I type like J, now is this the ASCII code for J? P is 29, space is 39. Are these the ASCII codes? You should use full relative paths and not CD things. Oh, I got swallowed. How do I get out of here? Oh, like that, okay. The scan code, so that's different from the ASCII code. I tried that. File equals bootloader. Does that work? Yeah, that works. Okay. But how about the assemble one? Bootloader. Bootloader. How's that? Showing? No. Yeah, because you have to be in there to use to include print.asm. So this one, I think, as far as I know, it has to use the CD. But this is super cool. Except it just goes off screen, and then what happens to it? Oh, and I keep eating my mouse. Showing. Okay. Very satisfying. Baby step 6. What's this one about? Entering protected mode. Oh yeah, now we're talking. These baby steps are only going to get me through protected mode, right? I need to get to long mode. Okay. So, oh dear. Monitor just bit it. Our entering protected mode is actually done by switching a single bit in a special register, CR0. My monitor won't turn back on. How's that? There we go. Okay. All the other stuff, like A20 line, task, IDT, call gates, etc., is additional stuff. However, before switching to P mode, you have to use the LGT instruction to load another special register, GDTR, with the location of a table of data structures called descriptors that tell the process how to access memory. Descriptors. Overview of bytes in the descriptor. Here's the bytes in the descriptor. Descriptor bytes are ranged from lowest memory location to highest. Lowest byte of limit, next byte, lowest byte of base address, next byte of base address, third byte of base address. These, fourth and highest, okay. Bits in type. In Teach Kai, you sent a tutorial that is more in depth. Let's see it. Broken Thorn. Is this for Nazem, Cat? Whole thing about bootloaders. And then all this. Prepare for the kernel. This is the second stage of the bootloader, I'm assuming. And then it goes into setting up. It even gets all the way to. This is really cool. Looks like it's for Nazem. This is really well designed, this website. Hello, Redstone. Wow, this looks way better. I like how it's called Broken Thorn Entertainment. And I like how these change colors when you hover over them. It's kind of a cool feature. It even gets into graphics. Look at this. A lot of reading though? It's not too much. It looks like it's a lot of writing too. It's all in C, so we'd have to translate some of this to lovely, no? Or we could just do it in C first and then switch it out with lovely later. You wouldn't even get to that for a while because this is still all assembly here. This is pretty cool. There's even like a chat room, forums. Newest things on here are from 2019. Does it go? It only goes through protected mode. It is more theory, so you will need to write your own, which is good. Uses box and not Kimu. What's box? Box. Think inside the box. Cool. What do you think? Should I go with this? This does look better. It only goes to 32-bit though. Am I sure I want to go to 64-bit? I mean, 64 is in theory better, right? Um, I do like how this will keep going. Okay, so you're saying this doesn't give me like all the code. It'll have me like actually write it out myself and stuff, right? Okay, some of this is just like overview of C and how pointers work and stuff in line assembly. Not found. Hmm. Just looking through this real quick. You only used a simple tutorial for the first hello world that you're making right now. And then just follow more theory and components tutorials on my own implementation. Gotcha. Well, maybe I'll stick with what I have for now. Finish these baby steps. And then we'll talk about where to go next. Because the baby steps have been pretty good. But this does look intriguing. I'm definitely gonna add it to my where'd it go? This, right? I'll add this to my OS dev resources. Cool. Okay, so anyway, back to baby step 6. This is just reading. So I'll just read through this, and then I think I might be done with the stream for today. It's been an hour and 15 minutes, right? So yeah, I'll stop it there. Finish just the one you started, and then maybe use this one for understanding what it does. Sure, maybe. Good idea. All right. P present, which is 1-bit. It means segment. 1 means segment is in memory. Accessing a non-present segment or is an exception. DPL, descriptor privilege level, 2 bits. 0 is most privileged, and 3 is, this is like the ring, no? S, system, 1 bit. Must be 0, and descriptors for task state segments. TSS, interrupts, gate, trap gate, task gate, call gate, otherwise. Okay. Type, 4 bits. Okay. Type it 3, type it 2. What are these all for? Well, how is this going to be used? For the global descriptor table? Is that what we're going to use here? GDT, sure enough. You need it to switch to protection mode. Gotcha. So then after this, we'll switch to... Okay, and then this is the last baby step. 32-bit printing. And that's it. So we'll end with printing in 32-bit mode. Cool. All right, I'll stop here for now. We'll finish these baby steps next time, probably tomorrow, and then see where to go from there. But cool. Thanks everybody for joining. Move ZX seems that it is a normal move that 0 extends the thing you're moving. Cool, okay. It was nice to see you, bye. So yeah, see you, Kat. Thanks for all the help. That's super helpful. All right, how do I stop this thing? See y'all.